Hi, thank you so much for your interest in the SafeTI Compiler Qualification Kit. This video will describe how to apply the kit to assist you in qualifying the TI ARM C compiler to functional safety standards and provide details of the kit's key components. First, I would like to introduce you to the presenters. I am Roy Haley from Texas Instruments Hercules Safety MCU Marketing Team. I will provide an overview of how to apply the kit. Oscar Slotosh, CEO of Validus, will show you how to apply the Qualification Support tool. Our TI ARM compiler expert, Tom Sahita, will show how to use the test automation unit. And finally, Marcel Beemster, a functional safety and compiler quality specialist at ACE, will provide details about the SuperTest qualification suite. Okay, let's start by talking about why we need to qualify the compiler in the first place. Part 4 of the IEC 61508 Functional Safety Standard defines software offline support tools and classifies them depending on impact. A T1 tool has essentially no impact on the executable code, such as a text editor. A tool is classified as T2 if it cannot directly create errors in the executable code. Typically, these are tools used in test and verification of software, for example, a static analysis tool. T3 tools are those that generate outputs which can directly or indirectly contribute to the executable code. The standard clearly calls out the compiler as an example of a T3 tool. Furthermore, IEC 61508 Part 3 specifies additional requirements for both T2 and T3 tools, including an assessment to determine potential failures and appropriate mitigation measures. For T3, further evidence is required, which can be provided based on tool validation. In the Automotive Safety Standard, ISO 26262, it is similar. Tools are categorized as either TI1, having no impact, or TI2, having impact on the safety function. Then you determine the tool detection level, or TD, for detecting or preventing potential errors. TD1 having the highest probability of detection, TD2 medium, and TD3 low, or all other cases. Once the tool impact and tool detection are known, you can classify the tool as being TCL1, TCL2, or TCL3 according to the table you see here. Normally, the compiler is classified as TCL2 or TCL3, and according to the standard, will therefore need to be qualified. Certified tools are normally those that have been through an evaluation of a tool development process, whereas the SafeTI Compiler Qualification Kit is a validation of the tool, which is required for higher ASIL levels as seen in the table. In summary, the functional safety standards require some form of evidence to show that you can detect or prevent the potential errors of the compiler. The SafeTI Compiler Qualification Kit enables you to validate the tool and generate the required evidence. Now let's walk through a quick flowchart to show how you would apply the SafeTI Compiler Qualification Kit. First, you need to classify the tool as we just discussed to determine if qualification is really required. This can be done using the free download of the Classification Support tool on the TI website. The web address is shown at the bottom of this slide. If you determine that you don't need to qualify the compiler, then you probably don't need the qualification kit and can manually document the analysis and assumptions that led to your classification. Otherwise, you need to qualify the compiler and will install the qualification kit. The first thing you use in the kit is the Qualification Support tool, or the QST. The QST is a GUI-based tool, which is where you will enter the specific compiler features you are using. This defines your specific use case of the compiler. The next step is to compile your application code using the instrumented compiler with the same features and options you defined in the QST. When you compile your application, the instrumented compiler will generate a code coverage report. The next step is to run the validation tests against the compiler based on the use case you entered in the QST. The QST outputs a test list based on the features you selected. The tests include the ACE SuperTest qualification suite and other TI compiler validation test cases. All tests are run using the test automation unit, or TAU, which will also generate a code coverage report. the code coverage reports from the instrumented compile of your application code and the TAU are then compared. If the code coverage from compiling the validation test cases is less than from compiling your application code, then additional tests or mitigations may be required. If additional tests are required, these are added to the test list and the TAU is run again to generate a new coverage report. This step can be repeated until the coverage is adequate. If additional mitigations are required, they are normally added to the tool safety manual to document how to avoid the potential error not covered by testing. The QST also generates the necessary safety documents, which you can then modify as required, including the initial classification report based on your specific use case. At this point, you have concluded your qualification of the compiler and have the necessary evidence according to the safety standards we discussed. I will turn it over now to Oscar to demonstrate the qualification support tool, which is obviously a key component of the kit.
Roy, thanks for the gentle introduction. Now let's come to the know-how and start the demo. We start the qualification support tool that guides us through the qualification process. It's like an installer, so the first question is where we want to run the qualification and where it shall generate the documents. That's an empty directory here. And now the installer asks us some questions like the standard to support or some specific variants and which tool we can qualify. And you see here the list of qualifiable tools. We choose the compiler and continue to configure the use case. This is the main effort to configure the use case by selecting here some features. For example, we select the assembly source code and we select the output file directory. So we have two different features and we have two different colors. So the green features can be used without any restrictions in the safety manual, while the pink features require to have some restrictions in the application. Well, which restrictions to apply can be selected from the potential errors. So for the assembly source code, we have those potential errors and we have test cases for them. For the feature output file directory, we do have other errors where we don't have test cases for it, and therefore we have to look what can be done. And for example, if changing the output file directory would impact the behavior of the generated output, then we can find this by an intensive target testing. If it does not generate an output at all, maybe the old file can remain, we will use a reference file list to detect this error. If the directory is wrong, we will review the build directory, and now we have mitigated all potential errors because review of build directory is detecting both of those errors. Well, now the background color changed, so if we look to this again, you see red means it's not sufficiently for qualification. We can't continue, but if we enable this check, we continue and see an overview of the documents that will be generated during qualification. Now I press finished and the generation of the document starts, and I can show you this. It's on the other window opened. I'll show you here the generation of the documents. It's generating the classification report, the tool qualification plan, and the tool safety manual. And all will be located in the directory that we have chosen here. We can go to the directory and wait some seconds for the documents to be generated. And now it's finished and we can see the results. You see those files have been created, so there is a qualification kit which contains here the templates that are used for the document generation, and it contains the model And furthermore, there is a validation which is concerning the current validation of the tool, and here we have the concrete documentation with the tool classification report, tool qualification plan, and tool safety manual, and we have here a list of test cases that has to be executed. This is a so-called test plan, and this test plan is fed into the test automation unit to run the test cases, and the test results will be then included into the tool qualification report. Well, how to execute the tests in the test automation unit is the task of Tom to explain us. So Tom, it's yours.
Thank you, Oscar. My name is Tom Suhita, and I am a member of TI's compiler group and the lead developer of the Compiler Qualification Kit's Test Automation Unit. The Test Automation Unit, or TAU, will run the required test cases that are generated by processing your use case through the Qualification Support Tool, or QST. These test cases include several hundred written by the compiler group, as well as the ACE Supertest Compiler Test and Validation Suite. Marcel will give further details about the Supertest Compiler Test Suite in the next section. It is important to note that the TAU comes from the TI production compiler validation process. All of the test cases and the scripts that control the running of the test cases are run during the validation of every TI production compiler. There are several requirements that need to be met to be able to run the TAU. These include at least 3 gigabytes of free disk space. Perl is needed, at least version 5.8.3 or later. There are 4 Perl CPAN modules that are needed, and they are listed on the slide. CodeComposer Studio 5.1 or later needs to be installed. The TAU uses the loader found in CodeComposer Studio to load test cases onto a hardware board. The TAU will run on Windows XP, Windows 7, or Linux. The TAU is a command line tool and will be executed from a shell window, such as a DOS shell. The TAU has been tested on several Hercules boards, including the TMS 570 LS3137 and TMS 570 LS1227 emulator boards. The TAU has been tested with several different connectors, including the XDS100 and XDS560 V2. The TAU also provides a way that it can be configured to your specific board. There are several steps involved in the operation of the TAU. First, you must generate a test execution plan for your use case from the Qualification Support Tool. You then convert the test execution plan into a TAU test plan by invoking a Perl script that is included with the kit. The next step involves editing a TAU configuration file. In this file, you will list your compiler location, which compiler options represent your use case, where CodeComposer Studio is located, and your board and emulator connection type. Running the test cases then just involves invoking a Perl script with the appropriate TAU test plan. Please note that the test plans involve running several hundred to several thousand different test cases. It will take several hours to complete all the test cases. The TAU test plans can be edited if some of the tests need to be rerun. At the end of each TAU run of a specific test plan, summary log files as well as detail log files are generated for all test cases. The Compiler Qualification Kit also gives you a way to check the code coverage of the compiler on the test cases and on your application. This provides a way to verify that the test cases do indeed cover your compiler use case features. The kit includes a release of your version of the compiler that will have been built to generate code coverage data on the compiler. The verification process involves two steps. An additional round of testing is run with the TAU test plans using the instrumented compiler. Second, the instrumented compiler is also used during a build of your application. This process involves collecting two sets of coverage data. One, the compiler code coverage on the TAU test cases that were run, and two, the compiler code coverage on your application. You then send this data to Validus and TI, and we determine two different things. Was there sufficient compiler coverage of your use case feature or features while running the test cases? If not, are additional test cases or mitigations needed to provide coverage of your use case? After our analysis, we respond back to you with our results. This completes the overview of the TAU. Next, Marcel will give more details about the SuperTest test suite.
Thank you, Tom. I want to tell you a bit more about one of the test suites inside the Qualification kit, and that is the SuperTest Qualification suite by ACE. SuperTest is the most comprehensive test suite for compiler conformance testing for C. In the SafeTI compiler qualification kit, we have more than 20,000 handwritten tests and over 2 million generated tests. I will tell you more about those generated tests in a moment. SuperTest includes more than 30 years of accumulated compiler quality assurance. That is why ACE is the industry's leading provider of C and C++ validation services. SuperTest already existed when the first proper standard for C, known as C89, was ratified. In 1999 a new C standard appeared, and just recently the C11 standard was approved, a document of more than 600 pages. SuperTest has grown side by side with these language developments. SuperTest has also grown from defects found in compilers that were not initially detected by SuperTest. ACE, as you may know, is also the developer of the COSI compiler development system. SuperTest and COSI are used side by side and keep each other in check. Furthermore, feedback from the many SuperTest customers gave us direction for SuperTest's expansion. Another tool that we use to grow SuperTest is ACE's so-called bug factory. It is based on coverage testing of the compiler source code itself. First, we run SuperTest on a compiler that is instrumented to record coverage. Then we create new tests for the parts of the compiler that are not touched by any test in SuperTest. I want to highlight one unique aspect of SuperTest, and that is what we call the depth suite. We build the depth suite because the C standard leaves certain parts of the language implementation defined. What that means is that the standard does not completely specify a feature, but it does say that the compiler implementation has to define it. That such features are a challenge to program portability is a well-known fact, but they are also a challenge to conformance testing. Probably the most visible implementation-defined feature is the bit width of integer arithmetic. For the integer type, the C standard only requires a minimum accuracy, but it leaves open to the compiler and the target architecture what that actual integer size is. Once the integer size is fixed, however, the standard has quite detailed rules about integer arithmetic. These are about constant folding, overflow handling, integer promotion, etc. It would be great if a validation suite could verify the correct implementation of these rules. The standard has made that rather difficult. The standard only guarantees 16 bits, so a general test suite cannot assume more bits. Take, for example, the expression 1000 times 1000. 16 bits is not even sufficient to compute its outcome, because the standard does not guarantee the bits required to represent 1 million. It is true that many of today's target architectures do have sufficient bits, but SuperTest cannot depend on it. SuperTest's answer to this parametric definition of integers is the depth generator. Instead of having a fixed collection of tests, we have a generator that we feed with the actual sizes of the arithmetic types. The generator then creates a collection of tests that do a complete combinatorial sweep of all integer expressions of up to 2 operations deep. This is what we call the depth suite. It is included in the qualification kit and it gives a very thorough validation of the arithmetic implementation. Okay, let me summarize the Supertest qualification suite inside the SafeTI compiler qualification kit. It is supplied by ACE and includes more than 30 years of experience in compiler validation. It is specifically constructed to build confidence in tools for functional safety applications. It does the most thorough testing of C compilers with high compiler code coverage. The depth suite provides a unique architecture-specific arithmetic validation. And of course, the suite is fully integrated with the SafeTI compiler qualification kit. If you want to know more about the Supertest qualification suite or the standalone version of Supertest that also includes C++ and other functionality, please contact my colleague Marianne at ace.nl for general inquiries or me, Marcel at ace.nl for technical info. And with that, I hand the microphone back to TI. Back to you, Roy.
Thanks, Marcel. As we have shown, the SafeTI compiler qualification kit was developed to assist you in qualifying your use of the TI ARM compiler to functional safety standards. Using the kit can be much less restrictive than using certified compilers because it qualifies your specific use case and can be applied to the latest revisions of the compiler. Application of the kit has been assessed by TÜV Nord to comply with both IEC 61508 and ISO 26262. The kit includes the qualification support tool, which Oscar demonstrated helps you classify your use of the compiler and determine what tests and mitigation measures are required. As you have seen, the QST also generates key safety documents, such as the tool classification report, tool qualification plan, tool qualification report, and the tool safety manual. The kit comes with the ACE Supertest qualification suite that Marcel showed, provides a high level of test coverage of the compiler and ensures ANSI C conformance as well. Test coverage is further enhanced by TI-developed compiler validation test cases. Tom showed how the test automation unit can be run in your environment on actual Hercules target hardware. And lastly, 24 hours of Validus consulting is also included to support you through the qualification process. We hope that this video has helped to show how the SafeTI compiler qualification kit can assist you in qualifying the TI C compiler to functional safety standards. The SafeTI compiler qualification kit is one more way TI and our partners like ACE and Validus are making it easier for customers to develop functional safety applications. For more details and ordering information, please go to www.ti.com/tool/SafeTI_CQKit. This link is also shown at the bottom of this slide. Thank you so much for watching this video.